The antiderivative. A function big F of x is an antiderivative, also known as a primitive integral, or most commonly an indefinite integral, of a function f of x if big F prime of x is equal to f of x for all x in the domain of f. The process of finding an antiderivative is antidifferentiation, the opposite or inverse process of differentiation. So big F of x, the derivative denoted by the prime, is equal to f of x. Find f of x for the given derivative function f prime of x is equal to 2x squared plus 3x minus 6. So f of x is equal to, if we look at this formula here, this integral symbol represents finding the antiderivative, or the indefinite integral. So utilizing this, we'll keep the constant in front. And x squared, so x to the 2 plus 1 divided by 2 plus 1, plus the constant times x to the 1 plus 1 divided by 1 plus 1, minus 6 x to the 0 plus 1 divided by 1, plus c. C is our arbitrary constant. F of x is equal to 2x cubed divided by 3, plus 3x squared divided by 2, minus 6x plus c. The constant value c must appear in this original function to account for all the possible constants that we lose when we differentiate. So let's say we have this very simple function. I'll call it g of x is equal to 2x plus 3. That means the derivative is equal to 2, because the derivative of a constant is 0, and the derivative of 2x is 2. But let's say g of x, I have a second g of x, which is equal to 2x plus 7. These are very different functions, but look at their derivatives are the same, because the derivative of all constants is 0. The derivative is 2. So these derivatives are the same, but their parent functions are different. So the c here accounts for all possible and infinite number of antiderivatives, for all possible and infinite antiderivatives for each given derivative, and the arbitrary constant c accounts for this idea as a notation solution for the issue. Antiderive f prime of x is equal to 1 minus the square root of x divided by the square root of x. So first, we have to apply some algebra, because we can't use this, so we have to manipulate it so we can solve it. So we can split up the numerator, because both aspects of the numerator share the same denominator, so 1 divided by the square root of x minus the square root of x divided by the square root of x is equal to x to the 1 divided by x to the 1/2, because the square root of x is x to the 1/2, minus 1, which is equal to x to the negative 1/2 minus 1. So f prime of x is equal to x to the negative 1/2 minus 1. So f of x is equal to, using the formula we developed in the previous slide, the exponent is increased by 1, and we divide by the new exponent, minus x plus c f of x is equal to 2x to the 1/2 minus x plus c. X to the 1/2 can always be written as the square root of x. Find all possible f for the given derivative f prime of x is equal to 1 divided by the square root of 1 minus x to the 4th squared times 4x cubed. So what we have here is very messy. We can't find this antiderivative using traditional techniques. But what we can do is recognize that this is the arcsin identity, and that the variable in the arcsin identity, so let's look at d dx of inverse sine or arcsin is equal to 1 over the square root 1 minus x squared. We can view x here as x to the 4th. So f of x is equal to sine inverse of x to the 4th plus c. Because once we differentiate this, we obtain this times the derivative of the argument, like other trig derivatives. Once we differentiate the outside, we obtain this, then we multiply by the derivative of the argument. The derivative of x to the 4th is 4x cubed. Antiderive f prime of x is equal to sine x minus natural log of x plus e to the x minus 3x cubed plus 3 times the quantity x squared minus 3x squared times 2x minus 3. So this is very complex and long, but we can do this fairly simply by just looking at each component individually. So using our knowledge of sum and difference in differentiation, we know that we can handle each bit individually. So let's say f of x is equal to sine of x. Therefore, f of x is equal to negative cosine of x. F prime of x is equal to negative natural log of x. Therefore, f of x is equal to negative 1 over x. F prime of x is equal to e to the x. Therefore, f of x is equal to e to the x. F prime of x is equal to 3 times the quantity x squared minus 3x squared times 2x minus 3. Therefore, f of x is equal to x squared minus 3x cubed. We then recombine all these elements and yield f of x is equal to negative cosine of x minus 1 over x plus e to the x plus x squared minus 3x quantity cubed plus c. We cannot forget the arbitrary constant c, because this allows the antiderivative to apply to all infinite number of possible normal functions and accounts for the information lost through the differentiation process.